Okay, so here's all four of the triangles drawn with terminal arms in all four quadrants. Now you won't always have to draw all four terminal arms, but it really depends on the problem that you're given. If you have an angle that's given, then it should be pretty obvious which quadrant your terminal arm will be drawn in. So for example, if the angle is given, and it's between 0 degrees and 90 degrees, you'll know it's in the first quadrant. If the angle is given and it's between 90 and 180, it'll be in the second quadrant. If it's between 180 and 270, it'll be in the third quadrant, sort of like the one that's here. And if it's between 270 and 360, the terminal arm will be in the fourth quadrant. Okay? Now, the only difference is if you're not given an angle and instead you are given the ratio, that's a little bit different. In that case, you need to determine which quadrant your terminal arm could possibly fall in. And that's where the terminal arm diagrams really come into play. One thing I want you to note is that all four triangles are congruent in this diagram that's here, and the base of each of these triangles is drawn along the x-axis. So you'll notice that the sides of the triangle are, one side is always against the x-axis and the other side is sort of hanging out at the end. Okay? So please remember that when you are looking at your terminal arm diagram, if you're given the angle, then that's fine. You'll know which quadrant to draw your terminal arm diagram. But if you're not given the angle and instead you're given the ratio, in that case you need to determine which quadrants you would need to draw your terminal arm diagrams in, and then you would go from there. Now, if you're given the ratio, most likely what you're going to be asked to solve for is the angle, and this little rule that we have down here is what will help you figure out what the angle or angles would be depending on which quadrant the angle falls in. So if the angle falls in the first quadrant, then your angle will be the same as your related first quadrant angle that's drawn there. If your angle falls in the second quadrant, the angle that you're actually trying to solve for starts at the initial arm along the positive x-axis and rotates across to the terminal arm in the second quadrant. So that's the actual angle that you would be solving for, which we would call theta. However, it's hard to find that without knowing what the related first quadrant angle is here. So once you know the related first quadrant angle here, you can actually solve for the angle that would land in the second quadrant. Okay, with the terminal arm that would land in the second quadrant. The way you would figure that out is, in the second quadrant, the rotation is almost 180 degrees, but it's a little bit less than 180 degrees. So what I would do is subtract that small amount that it's less than 180 degrees from 180 degrees to actually figure out that angle of rotation. So 180 degrees would get you all the way here. This angle of rotation is a little bit less than that, so I would be subtracting. If the angle was in the third quadrant, then that would mean that my angle of rotation would continue onto the third quadrant, and so it would continue going this way. And so you'll notice that this angle is a little bit more than 180 degrees. So I'm going to add that little amount that's a little bit more than 180 degrees. And you'll notice that that small amount is actually the related first quadrant angle. And so if I add that to 180 degrees, then I can find the angle in quadrant 3. However, if the angle continues to rotate and you have your terminal arm diagram in quadrant 4, then the angle you're looking for goes all the way around here. And you'll notice that this is actually almost a full rotation. It's a little bit less than a full rotation. A full rotation is 360 degrees. And so the amount that's a little bit less than a full rotation is this related first quadrant angle that we have here. And so if I wanted to figure out what the angle is in the fourth quadrant, I would subtract that small amount that I have here, which is the related first quadrant angle. So you'll notice that all the angles in quadrants 2, 3, and 4 depend on what the related first quadrant angle is in order for you to find the full angle in those 3 quadrants. Okay, so there's something else we're going to be using, and it's called the cast rule. This is very important. This is something that you should definitely remember for the test and whenever you're doing any of your homework. So just remember what we looked at earlier in the lesson, where we looked at sine, cosine, and tangent based on x, y, and r. What the cast rule helps you determine is a quick way for you to see which quadrants the trig ratio will be positive in. Okay, so what cast here spells out, and I know it starts in the fourth quadrant, goes up and across. So what cast means is A represents that all ratios are positive, so that means the sine ratio, the cosine ratio, and the tangent ratio are all positive. Sine means that S means that only the sine ratio is positive, T means only tangent's positive, and C means only cosine is positive. Now, why does that happen? Well, the reason why that happens is because of what the values of X and Y look like in each of these quadrants. So, for example, in the first quadrant, X is positive and so is Y. So, what that means is if I plug in positive values of X and positive values of Y in each of these ratios, I get a positive number. R will always be positive because it's a radius, so it's the distance between the center of a circle and the edge, basically. So that'll always be positive. Only X and Y might change. And so if I plug in positive numbers in X and Y and R, I get a positive over a positive, positive over positive, and positive over positive. What happens here is when I divide two positive numbers each time, I get a positive ratio as a result. Okay, so A here represents that all of the ratios are going to be positive. In the second quadrant, because we're moving to the left, I know my X values are going to be negative, and because I would need to move up, I know my Y values are going to be positive. So if I plug in those values that have those kinds of sign for X and Y, what will end up happening, and I don't know why this is smudged, but sorry, hopefully you can still read that. If I plug in positive and negative values based on what my X and Y values are here, think about what happens. If I plug in a positive value for Y, since I have positive values for Y in the second quadrant, R is positive anyways. Negative here, positive here, and negative here. Notice what happens. When I divide two positive numbers, it's still positive. When I divide a positive and negative, it becomes negative. And when I divide a positive and negative, it becomes negative as well. So the only ratio here that will remain positive is the sine ratio. And that's because I'm dividing two positive numbers. And so that's what the S here means. Only the sine ratio is positive in the second quadrant. Okay, the other two ratios will be negative because your adjacent side will be negative. And so as a result, you'll get negative values there. Okay. In the third quadrant, you're moving to the left and you're moving down. So that means X is negative and Y is negative. And so what that means is I'm plugging in negative numbers for X and negative numbers for Y. So I'm just going to modify these. So you know what? I'll just leave these as positive because the radius will always be positive anyways. But now I'm plugging in negative values for Y and negative values for X as well. Okay, and so now I have negative over positive, negative over positive. Both of these will give me negative results. However, here I have negative over negative, which means I'll get a positive result when I look for the ratio for tangent. So, and if you notice here, T represents tangent in that quadrant, so only tangent ratios are positive here. Same idea for cosine. Cosine, if I moved in the fourth quadrant, I would need to move to the right, which means X is positive, and down, which means Y is negative. And if you think about what would happen as you plug in negative values of Y, positive values of X, negative values of Y, and positive values of X, the only ratio between these three that will remain positive is the cosine ratio. And so that's why the C is here. So what each of these letters mean are which ratio is positive and in which quadrants. So we're going to look at some examples. Example 1 says, draw a terminal arm diagram for the following trig ratios where theta is between 0 degrees and 360 degrees. So all we're doing in this case is we're looking at what the terminal arm diagram would look like, and because we're looking at a full rotation, we want to consider all four quadrants. So what I would think about is if I'm given a sine ratio that's a positive value, I need to figure out which quadrant sine would be a positive value in, and we're going to use the cast rule to help us figure that out. So on the side here, I'm going to draw the cast rule, and using the cast rule, I'm going to determine which quadrants the sine ratio will be positive in. So the sine ratio is positive in, depending on where I'm looking at in the four quadrants. The sine ratio will be positive in the first quadrant and the second quadrant because all ratios are positive in the first quadrant and only sine is positive in the second quadrant. So if I'm drawing my terminal arm diagram, I would focus mostly on the first two quadrants, and I would have a terminal arm in the first quadrant and a terminal arm in the second quadrant. And what that means is I could potentially have an angle between 0 and 90 degrees, and another angle between 90 and 180 degrees, okay, because of the fact that the sine ratio is positive, and the first two quadrants is where the sine ratio will be positive. Okay, for part B, I'm looking for where the cosine ratio is negative. So, I know it's positive in the fourth quadrant, and I also know it's positive in the first quadrant. So that means the other two quadrants, it's going to have to be negative in. So this tells me the angle will be in quadrants 2 and quadrants 3. So when I draw my terminal arm diagram, I'm going to focus mostly on quadrant 2 and in quadrant 3. So my angles have to be in quadrants 2 and quadrants 3 in order to get a negative ratio as a result. So here I'll just show you what I mean by this. If I choose an angle that's more than 90 degrees but less than 180, so I'm just going to draw my numbers here. You don't have to draw this each time, I just do it to show you. So let's say I have an angle of 100 degrees. So that would be in the second quadrant. If I find the cosine of 100 degrees, what I end up with is a negative ratio as a result. So that's what I mean by a negative ratio. Okay, so in case you were wondering what negative ratio means, that's exactly what I mean. Okay, same thing if it was an angle between 180 and 270 degrees. So let's say I have a 200 degree angle. If I try to find the cosine of a 200 degree angle, I get a negative ratio again. Okay, so that's essentially what we're referring to when we say a negative ratio. Okay, last one. I have tan theta equals a positive ratio. So again, let's look at the cast rule, and we're trying to figure out where tan is positive. So I know it'll be positive in the first quadrant since all of them will be positive there, and also in the third quadrant. So my angles in this case would be in quadrant 1 and in quadrant 3. So if I was drawing my terminal arm diagram, I would draw a terminal arm in the first quadrant and a terminal arm in the third quadrant as well. Okay, so that tells me one of my angles would be between 0 and 90, and my other angle would be between 180 and 270. Okay, and we're going to look at some examples where you actually have to solve for the angle.